Hi, this what you see is a 220 volts copper shading ring induction motor with a coil resistance of up to 160 ohms, and today in this video I'm going to turn it into a transformer. Hey, did you know that your most valuable details like your bank account information, passwords for online activity, emails are all at a great risk because hackers are targeting your internet activity without any VPN protection and an exposed IP. So don't wait. Choose the best NordVPN service now. Please note that huge discount is available for first 1000 buyers. Both link and your coupon code are available in the description, so grab it now. So before moving on with the project, let's check if it is working or not. This motor is usually found in hot air blowers. As you can see that it is working just fine. So now I'm going to proceed with the project in such a way that neither should I destroy the motor nor should I abandon my project. So guys, after completing all that, here I've taken a copper wire of thickness 0.4 mm and I'm going to use this wire as the secondary winding for the coil. First, I'm planning on giving around 50 turns and then check how much volts I'm getting and then accordingly increase the number of turns if needed. My target is 12 volts. So our transformer is ready for the first test. To the main input coil, the primary coil, I have connected the 220 volts supply, and at the output I have connected the multimeter terminals. Let's turn on the switch. As you can see that the output voltage is 5.5 volts AC. Let's close the magnetic circuit of this transformer with the help of a metal piece. Testing it again. Now as you can see that the output voltage has increased from 5.5 volts to around 6 volts AC. So it is exactly half of what I need. This means that I need around 100 turns at the secondary. So guys, here I've completed full 100 turns for the secondary winding. Now this is a piece from a universal motor, so I'm going to use it to close the magnetic circuit. So yeah, now it looks like a transformer. Let's test it. Okay, so connecting the supply, turning it on. 12 volts, exactly what we needed. Now this what you see is a 12 volts 3 amperes car bulb, and I'm going to connect this bulb to the transformer to check if it can handle this much load. It is around 36 watts. Okay. It is actually working. Pretty good, huh? Now let's turn off my camera light as well, turning on the transformer. You can see that it is working really nice. Turning it off. This what you see is a KBPC 3510 bridge rectifier for converting the AC output from the transformer to DC. So I've already connected the AC terminals to the rectifier. Now comes the final output DC terminals. So for the output, I'm going to use the black and red jumper cables. Red will be positive and black as always negative. Now let's do the short circuit ampere testing. So turning it on. So the amperes are 1.36 at short circuit. Now I'm going to turn on the switch. Keep concentrating on this wire. Okay. You see that it is vibrating at such a high speed. Well, of course, there is a lot of ampere loss in the cables. But if we go for the direct test, the output should be a little better. You see, amps have increased from 1.36 to around 1.75. So let's start the test with this LED panel, 84 LEDs. Turning it on. Glowing pretty bright. Really good. Moving on to our next appliance, which is a 40 watts 12 volts car headlamp bulb. Let's turn it on. Okay. You see, it's glowing fully bright. Okay. You see, so bright. The transformer is actually working very well, more than I expected. Now let's move on to some motor loads. This what you see is a 24 volts 16,500 rpm DC motor. So I'm going to run it at 12 volts, so the rpm is going to be around 8,000. And before that, let's check if it runs. Turning it on. Hey, you see, it's working pretty good. There's sparking in the brush and commutation. Now let's try this 50 watts photocopy machine motor. So let's connect the final wire. Okay. You see, it's working pretty good. Once again. Now guys, the applications for the same are limitless, so it is for you to decide if you would like to use it for operating lights or motors or charging your 12 volts batteries. Hi, this what you see is a really big battery, quite old and from Exide Sonic. It's a C20 150 ampere hour tubular inverter battery. These four are the wires coming out from the battery case, which then are connected to my 1500 watts pure sine wave inverter for turning on my lab lights and power tools. Although I still don't have a charger for this battery, so I decided to make one with this computer UPS transformer. This side is 220 and this is 12. Even though the 220 volts side has many wires, we have to choose any two, keeping this black wire common for all the three cases. Here the meter is being pointed at AC voltage measurement mode and the pinouts are connected to the output of the transformer. So guys, output voltage result for yellow and black pair is 16 volts, as you can see. Choosing the other wire, green, output voltage for green and black pair is 13.77 volts, very close to our requirement. Let's try blue. Output voltage for blue and black pair is the maximum 19 volts and the transformer core is vibrating. Let's measure the AC output current at an output of 13.77 volts using this bulb. So turning on the switch, the output current is as high as 7.5 amperes. Oh! Now for charging the battery, we need to convert the AC output from the transformer to DC using this bridge rectifier. Don't forget to add a capacitor at the output as well. AC. The meter has been pointed to DC voltage measurement mode and the output is taken from the capacitor with rectifier and transformer connected before them. Let's turn on the switch. As you can see that the output voltage is as high as almost 18 volts, which is too high for any 12 volts battery. Batteries are going to die. And initially you saw that for AC voltage measurement, the output was only 13.77 volts. Why is that? That is because the AC voltage always keeps on changing from 0 to peak and then again from peak to 0. Therefore, the meter measures the AC voltage in RMS form, which is root mean square. But in case of DC measurement, especially when the power supply is connected to a capacitor or a battery, the meter has no choice but to measure the voltage at which the capacitor or battery is charged at, which is always the peak value, and peak value is always higher than the RMS value. So for that reason, I had to test so many different types of UPS transformers. And finally, the best results were seen for this transformer. It's a high current center tap transformer. Here I'm using the black and yellow tappings for the input. Now let's connect it to a 220 volts power source for testing it. Here as you can see that the output voltage is exactly as we need, between 14 to 14.4 volts. Let's do some current measurement using my 12 volts 100 watts car headlamp bulb. Okay, so turning on the switch. It's producing around 10 amperes. So at present the output is close to 120 watts. So guys, that's my inverter battery, and you see these two thin wires, red and black. These are coming from this electric exercise bicycle. The battery voltage, as can be seen, is 12.45 volts DC. So guys, here I've connected the power supply to the input, and the output from the capacitor has been connected through this wire and clips to the terminals of the battery. And here it is feeding the battery with 4 amps. And if we go for the change in battery voltage, it's 12.79 right now. Let's check the diode temperature. Yeah, it's quite hot. This is a 12 volts 21 amperes battery pack, and if we see the overall voltage, it is only 12.15. so let's connect my battery charger cables, red and black, to this battery pack. You can see that the voltage has started increasing, indicating that the batteries have started charging. Now because this battery pack is only 21 amps, but the battery that I showed you before was 150 amps, so obviously this is going to charge much faster than that one. So as you can see that the battery is charging, and our circuit or this battery charger is working really good. So with that, I'm finishing off the video. See you in the next one. Bye bye. Hit like and don't forget to share and subscribe. This is a microwave transformer, and these are my 100-watt LED lights with a voltage rating of 110 to 220 volts. A few months back, an accident occurred in which I lost one of my LED lights because the output voltage here in India is much higher than the rated 220 volts. It is up to 250 volts AC and sometimes even higher. Therefore, I decided to make this project.
Next level. Next level.
So guys, here I've tightened up the transformer core, and I'm using this green wire as the secondary, which is for testing the output voltage that I'm going to get, and accordingly how many turns I have to provide. Here as you can see that I've given 5 turns. The secondary voltage with 5 turns is 6.78 volts AC. If for 5 turns I'm getting around 6.8 volts AC, then for how many turns am I going to get 120 volts? 88.23, so 88 turns. The primary winding on the transformer, as you can see, is made of aluminum and the size is 1 mm. And for the secondary 120 volts winding, I am again going to use 1 mm wire but of copper.